All right, section 1. Troubleshoot basic virtual server connectivity issues. Our Objective 101 says, given a connectivity troubleshooting situation, consider the packet and the virtual server processing order in which the F5 takes in and processes packets. So what they want us to do is to be able to explain how a packet is processed once it arrives on the F5 device. The very first thing F5 Big IP platform is going to do as a connection arrives on the Big IP is it's going to look at its existing connection table to make sure that if this inbound connection is a part of an existing connection in the connection table. If it is, it's going to allow it to continue the flow and continue the conversation by letting it in to do what it was already doing prior. This is the first thing that's going to take in a packet on the box. If there is no existing connection in the connection table, the next order of operations for the operating system is to see if there's a packet filter turned on, enabled, and if there's a packet filter definition that will block or disallow this traffic to happen. So if there is a packet filter enabled, is there a packet filter rule that blocks this traffic or allows it, for that matter? The third part of the processing order is now a listener. It's the virtual server. Is there a virtual server configured on the Big IP platform that is listening on the IP port combination that is being connected to that allows traffic to be taken in on the box and processed? So our third step is a virtual server. Our fourth is a SNAT. Now most people, when they think of SNATs, they think of turning on SNAT auto map on a VIP to solve a VIP bounce back problem like we discussed in 101 class, or to solve asymmetric routing problems. Usually it's a routing problem that we're trying to solve with the snatting function. However, you can also set up SNAT translations on the box that are much like a PAT in a Cisco world, where we're snatting a group or a range of IP addresses outbound to a single IP address. This is very, very common when we're talking about having an organization surfing the internet out through a device, and you've got a lot of private address space trying to get out to the public address space, and they're all being natted, padded, snatted on the way out via IP address to a publicly routable IP space. The function of that type of a SNAT technically is a listener, because on the box, what it's going to do is it's going to say, I'm listening for anything coming from this range of IP addresses, and that depends on how you've built your SNAT, and it is a global listener on the F5, depending on the configuration you've done to configure that SNAT. And what it's going to do is it's going to say if it's coming from any one of these defined IP addresses, take in the packet, then translate the packet's source IP address to a new source, which would be one of F5's IP listeners, and then place it on the outside network or the other network so it can traverse to where it was trying to get to. So that SNAT is a listener, and that does take in traffic as our fourth order of processing for packets. Our fifth is a simple NAT. It's a one-to-one portless NAT. It is a stateless function. So this is very common when we see the subnet behind the F5 architecture on the Big IP platform doesn't have routing capability within the network. We route the front side VLAN but not the back side VLAN within the routing table of the company, and they don't want the rest of the company maybe to know about that subnet within their network. So they use a one-to-one mapping of the front side VLAN IPs to the backside VLAN IP addresses so that administrators can still administrate the back-end boxes that are on that private subnet, things of that nature. And that's what a NAT would do for us. In that case is where a NAT would be a listener. We're listening for that NATed IP address. If it doesn't match the NAT, we've now said, okay, it is not an existing connection in our connection table. It's not matching a packet filter to be blocked. It doesn't match a virtual server listener. It hasn't matched one of our snatting function listeners that we may have or may not have on the box. And it's not a NAT, one-for-one for us. Our next listener that it could be destined for that would make F5 take in or process a packet would be a self IP. Is the inbound connection coming to one of our self IPs? That could be our physical self IP or our floating self IP address on any of our VLANs. Now, when we start talking about listening on a self IP address, there's a lot of implications there around, are we listening on the port or are we doing port blocking on those IPs? And in most scenarios, when we're architecturally deploying an F5 big IP platform, we're actually doing port blocking so that we're not listening on a lot of those common ports, especially our administrative IP address ports, IP address and port combinations like 443 and 22 for SSH to the self IPs. However, if it does match and we are listening, we will take it in and we'll process it. That would be our sixth process. Our last process is a drop. This process, the fact that we're a default deny box is where the seventh step or our drop function comes into play. That would be the main reason why we are such a strong platform and have been for many, many years when it comes to security. If you as an administrator have not configured a function on the box to listen and take in and process traffic, we are not letting it in. And this is where the seventh step comes into play. Our next objective for 101 is going to be explaining how a virtual server processes a request from most specific to least specific. And that sounds pretty simple because yesterday we had this discussion around if you were given a route table example, which route would win for the destination path, right, in the 101. And that conversation around how that works is usually most specific path wins. And in this case, when we're talking about a virtual server processing, we may have hundreds of virtual servers configured on our F5 big IP platform. And when we have a lot of these virtual servers configured, sometimes and quite commonly, more than one of those virtual servers could listen and take in the connection. But when you build these, you may have a more specific listener as a virtual server than you do for others. And so there is an order of operations there when it comes to that most specific to least specific listener. Our first precedent here of the algorithm that's choosing which virtual server to process the traffic on that may be a match is that the virtual server that has the longest subnet match for the incoming connection will win. And I'm going to read through this because it is the logic of it. But in a minute, we're going to see some examples and be able to choose which one it would be. If the number of bits in the subnet mask match the algorithm, the algorithm then chooses the virtual server that has the best port match or the most specific port match. So now we've figured out what IP address is the most specific and then which port match is the best. If there is no port match found, the algorithm will then fall to a wildcard server, meaning a splat for port. And then if the wildcard address, if we've got a wildcard address, not port, but address, has a net mask length of 0, it has a lower precedence than one with a specific mask, and then also specific port, and then specific or less specific splat on the wildcard subnet mask. All right, so let's look at some examples. Given a specific connectivity issue, isolate where the problem might be according to the processing order. So if you were given a list, and this may be an example of something you might see on the exam, if you were given a list of IP address port combinations that are listing as virtual servers on the big IP platform, and you were given a connecting definition of how a user would be connecting, could you define which virtual server would process the packet? So if you look up into this list we have in this example, we have a 10.0.33.199 virtual server listening on port 80. We have that same IP address defined listening on all ports, or a splat. We have a network listener on 10.0.33.0 listening on a 24-bit mask on only port 443. We have the same subnet, same mask listening on all ports. And then we have an all zeros listener on port 80 and an all zeros listener on splat. So these are our 6 different virtual servers we have configured on our big IP. And as you see connections coming in from a client headed to 10.1.33.199 on port 80, we would say which one of these listeners would take in that packet and process that packet. Because obviously we don't have an existing connection, because you're looking at that processing order we discussed in the beginning. And we don't have any packet filters turned on to block it. And now we're at our virtual servers, and these are the 6 we have. So if you were to look at this and look at our list, which one would process this packet? Well, when I start looking at the IP he's coming to here, He's coming to 10.1.33.199, and I do not have a virtual server built on 10.1.33.199. I have one built on 10.0.33.199, and I have a network mask listing on 10.0.33 on a 24-bit mask. So the listener that would take this traffic in is actually number 5, are all zeros on port 80, because he is coming to port 80 traffic, and that is more specific than a splat listener would be for the all zeros. So if you were asked which one of these 5 would take that in, it would be all these 6, number 5 would be the one that takes it in. Our next connection is to 10.0.33.196.443. Well, if I look at my virtual servers that are built up here, I do have a listener for 10.0.33.199, but not 196. So it won't be 1 or 2, and it could be 3 or 4, because that's listening for anything in that 24-bit subnet mask. And 196 falls in that 24-bit subnet mask. And the first one, number 3 here, matches the actual port. So number 3 would be the one that takes that packet in. These are examples of the types of traffic flows you would see coming in from clients. And for you to be able to quickly discern which virtual server is processing the traffic is very important. The way F5 may present this to you is actually a screenshot of the GUI, showing you this list of virtual servers and their current statuses, and then it may give you that question that says, your customer's coming in headed to this particular destination IP port combination, which one of our virtual servers will process the traffic? What you need to be aware of is that when I start looking and saying number 3 is definitely the one that's going to process this traffic, you need to also be aware when you're looking in the GUI of what is administratively up or down, or what monitors have been succeeding or failing and that may not be answering, right? So there's a lot to take in when you're doing these tests, and this is why I say I could read a book, and I could be knowledgeable enough to say I understand how this functions and works, and I could figure out that one's going to go to number 3 and not number 1 or 2. But if you have never been in an F5 interface before, you're going to need to get familiar with what you're looking at visually. What are some of the things inside the interface that tell you what actually is listening and what's not listening? Even if it's configured to be listening, it may not be up, right? Things to be familiar with. We have others here. 10.0.33.199 and 443 would obviously go to number 2 because it's listening on all ports, and we don't have a specific 443 listener here defined. So those are just some of the examples. All right, so still looking for a way to identify a reason for an unresponsive virtual server. Maybe, and so far we've said that I can't get to that virtual server maybe because it's not up, even though, or maybe I don't have a listener that's going to take in the traffic that's coming to me, so it's getting dropped. It's actually falling all the way down to step 7 in our processing order. You need to be able to determine the state of the virtual server. Is it offline, enabled, etc.? And there's many ways to do this in an F5. We can actually go into the GUI and have a very great visual representation of what's going on. The GUI in the F5 Big IP platform is one of the best in the industry. And I'm not just bragging to you because I'm standing here in F5's headquarters recording and I work for F5. I've been doing networking for many, many years. And the web interface on the F5 platform is one of the most usable in the industry. And it's very easy to understand when you're looking at it visually. When you're looking at a list right here of your virtual servers that you have built on your platform, and I have just 3 as examples here, you get a lot of information just from looking at your list of virtual servers. I'm not even in our network map. I'm just basically looking at this list, and I can see that I've got 3 virtual servers configured. I have their IP destination listeners and their ports they're listening on visible to me right here inside this list. I can see their status, and right now we're going to talk a little bit about how statuses work. So we have 2 virtual servers, and both of them are green, and when we see green circles, we think go. Things must be good, that means go. I'll agree with you that things are up, and the very next connection coming inbound to either one of these 2 virtual servers that are green is definitely going to get processed and handled. Will the very next connection get processed or handled? That's unknown, but we know the very next one should be able to be processed or handled. I'm not going to talk too much about this blue one yet. We're going to get to that. But this is our status state that you can view in the GUI. There's other places to get this. Like when you're looking at the same status state and you see different statuses here, you're going to be able to tell what's going on as we discuss how our status states look and how they work. In this case, you see that we have our P80 virtual is now a black circle rather than a green circle. And what this one's going to mean for us is it's administratively down. Let's keep going through here, those clicks. You can see these same two virtual servers now in the configuration are red diamonds, and this means that they are offline, they are not working. Currently down, basically. So when we look through our status indicators, I know this screenshot may look a little poor for you because I've got green circles, I've got yellow triangles, red diamonds, and yes, this is a diamond, not a star, and the stretching of the screen looks a little odd for us. Black circles and blue squares. Our virtual server statuses are based on these icon indicators. So green is telling us that the virtual server address is enabled. It's up and able to receive traffic. Health monitors are succeeding. Red diamonds mean that the virtual server address is enabled, but it's offline because our monitors are failing. Yellow triangles tell us that we have set a connection limit, and that connection limit is currently being reached by our inbound connections coming in from the clients. You'll rarely see this one. Why? Because to even see this, you have to have a connection limit set. If you have no connection limits set, then you're never going to see this icon come up. If you do have connection limits set, you're only going to see it when you're hitting that limit. If I have 100 connection limits set and I'm hitting 99, if I'm at 99 connections concurrently right now, I'm not going to see this icon. When I hit 100, it's going to go to a yellow triangle. And I won't be able to take the 101st connection because I've set the connection limit. So that one's a rare one to see, but it can be one of our icon colors and shapes. A blue square here is telling us that the status is unknown. What does that mean for you? That means that you, as the administrator of the F5 Big IP platform, has not set a monitor within the configuration of this operating system for this virtual server to have a status rolled up to it. And what that means is that F5 will take in the packet and will create that three-way handshake in that full proxy architecture, and it will choose the best server in the pool to send it to. But because he doesn't know if any of those pool members are up or not, because we don't have a health monitor assigned, he's going to send it to the best one according to the algorithm. Whether it's up or not, he doesn't know. So if you see a blue square, it just means I am not doing any health monitoring for that resource. I've saved this black icon for last. Why? Because this black circle could be a black diamond. It could be a black square. The reason what it means is to say that the virtual server address or configuration is operational, right? But it's been disabled by you as an administrator. You've said, I don't want anybody to connect to this listener on the F5 or this resource inside the F5 Big IP platform. The shape here is as important as the color. So if I have a black circle, that tells me that the shape is the same as a green circle, right? So it's a circle shape. And what the circle told me was that our health monitors were succeeding, right? And we were enabled and would take traffic. So the green meant enabled, the circle meant the monitor was succeeding. So if I have a black circle, that means that my monitor that I'm sending is still being received by the server and I'm still getting a successful response back. However, as an administrator, I said I don't want any traffic to go to this resource. If this were a black diamond, that would mean that I, as an administrator, have said I don't want any traffic to go to this resource, but also that the health monitor I'm sending is failing and not coming back correctly. So if you see a red diamond, it means something. If you see a green circle, it means something. But if you see a black or red diamond or circle, it means the same things as far as monitoring status is concerned, but what it means is that I've got an administrative override to say I don't want resources being connected to. Same thing for your squares. Administrator, you may not have a monitor assigned, so it's a square. It's black because an administrator has marked it down. I can go in and look at my objects' statuses or states in the command line as well. And here you can see I'm doing a show LTM virtual, and it's bringing back, and this screenshot would be a lot larger if I took the entire output of this command and pasted it in here. It'd be hard to read, it'd be an eye chart. So I just cut out the very top of the output for the virtual server, for network access virtual server. And you can see that my state is enabled. My availability right now is unknown. And there's output for you. We need to identify the reason for an unresponsive virtual server by determining if a virtual server is configured for the proper listening port. So this is pretty critical. When you're configuring the Big IP administratively, typically you're not the guy who's controlling all the servers and how they're built and configured. They're coming to you as an app team and saying, we need you to load balance our application. Here's the IP of all of our servers so you can build your pool. Here's the port numbers we're listening on. And then we want to listen for this DNS name for all of our users to come into us on HTTP. That's what we want. And you're like, okay. So you go in to build your virtual server, and as you're building that virtual server, you remember they told you that's the name, so you're going to build it by IP address. So you're going to go out, do a DNS lookup on the name. You find their IP, you put it in the configuration. They said HTTP, so you put in port 80. You configure the whole virtual server out with all the properties you think you need for their application. You configure their pool, you build it out with all their members of their pools, all their IP addresses they gave you on port 80 like they told you, or on HTTP like they told you. You get it all built out. You go to connect to it and it doesn't work. And you're scratching your head, you're going, I don't understand why it doesn't work. So you go back and talk to the team and they said, oh, well, we need you to listen on 8080. Well, 8080 is still HTTP-based protocol, but when they said HTTP, you assumed 80 because that's the default port for HTTP. So there is a way where you could go out and configure at an IP level because they gave you a name, and when you translated the name in DNS, you got an IP address, and that's the one you used. Or they told you a protocol, and you picked the default port for that protocol, yet they were using a different port for that protocol on their back-end servers, perhaps, because maybe they're running Tomcat or Apache, and they're not listening on 80, they're listening on 8080 or 8081. So there is a way for you to go in and look at this. If you go in and look at your virtual server list, you can see what ports you're listening on that you configured. It's a very visual representation. You could click into any one of these virtual servers and see that same detail. Are you configured the proper IP address? Maybe how you DNS resolved the name, resolved to an IP address they weren't expecting. Perhaps they gave you the wrong name. Things can happen to that effect. And is it your fault that something's not up? Well, you configured the box, but they gave you misleading information. There can always be an issue around this. So it's an easy way in the configuration to go see everything you have is to get into the GUI and look around. If I were to click onto any one of those virtual servers, in the General Properties tab, I can see the IP address I'm listening on, the port I'm listening on, whether or not I've set it up to be enabled. I can even build some source restricting lists of what IPs are allowed to connect to me if I want to, things of that nature. I can go in and do a list LTM virtual. I can see my virtual servers and all the configuration I'm using on them, including the IP address port listener that I've got configured and set up for this particular virtual server. Many, many different ways to administrate the box and to see how you're configured. It doesn't just take GUI. It doesn't just take command line. You don't just have to go in and look at configs. There's many, many different ways to do it. And the GUI is extremely usable. I know a lot of the people that come to my classes are very network ingrained. They've done command line their entire life. They are Unix, Linux-based people, and they're really surprised at how well the GUI works for F5. Because in most platforms in the network, the GUIs are almost a secondary thought. So for those of you who grew up in that GUI age and didn't grow up in command line, you're going to feel right at home. And for you that are command line people, you've got a full-blown, robust command line system, but you can also use a very usable GUI if you need to. And there's sometimes a very nice visual representation within a GUI. Lets you think faster than to have to read out a whole page worth of config to understand what's going on. All right, determine if the virtual server is configured with the appropriate profiles. This one, for most of the new trainees that have never really worked with F5 a whole lot, is the most intimidating section of the configuration, I think. When I look at what I showed you a minute ago was the basic configuration of the virtual server, what IP am I listening on, what port am I listening on, am I enabled, what type of a virtual server am I. When we get down into the configuration section of a virtual server, this screenshot I have up here is actually 2 panels cut in half. So there's a cut here, and I'm showing you what's a scroll down would be. And every one of these sections of the configuration are settings you can tune and set for each virtual server you configure. There's a lot to take in here. It's almost an eye chart, especially if you're a few rows back in the class. I don't know how it's going to come out on the video. I hope it comes out very clear for you. You can go look at this for yourself as you log into your VLab's Big IP, or if you've got one in your lab, you can create a new virtual server and take a look. But this is where we assign profiles and all of the settings that tell the F5 virtual server how to process the traffic that flows through the box. So My number 3 listener in my process is the virtual server listener. That listener is listening on an IP port combination that's going to take in the traffic. Well, now that it has taken the traffic into the box, what's it going to do with the traffic? How is it going to process that traffic? These are the settings that tell the big IP what to do with your traffic as that client comes through the box. So how you set these profiles up could make your virtual server unresponsive. If I've gone in and configured my big IP platform on this virtual server to listen on an IP address port combination that it's a 443 based combination, and I take in that traffic and I terminate SSL by putting in an SSL profile client side, which takes the conversation between the client and the big IP and de-encrypts that traffic and makes it clear text. And I've got that all set up correctly by putting that on there. And the pool definition that I created on the back end of my pools are defined on 443. And I forget to put on the SSL server side profile, which would tell the big IP platform to re-encrypt the traffic as it sends it out and makes the connection to the back end server on that full proxy architecture. I've now taken in encrypted traffic, made it clear text, and then I sent it on to the back end servers clear text on port 443 as they're defined in my pool. That conversation is not going to work. The servers aren't going to be able to process the traffic. And so what you may experience is a virtual server that seems to be unresponsive or not work. Because of how I configured the settings, the F5 is doing what you told it to do. It's processing the traffic the way you've told it to process the traffic. However, the way everything was set up is not conducive to it working. Other things can happen along the way. Maybe I didn't assign an HTTP profile when I needed it. There's plenty of stuff here. Now, each one of these profile types that we're talking about here as far as our unresponsive virtual server is concerned, tell the F5 Big IP platform how to process that particular type of traffic. If I go in and I assign an HTTP profile, I obviously am processing HTTP. So I should have been listening on an HTTP-based port, and I should have HTTP-based traffic coming to that listener, because that's what I expect to happen. And then my profile would tell the virtual server how to process HTTP-based protocol through that virtual server. And there's a lot of settings here. So if I go into my profiles section of the GUI, and I configure an HTTP profile to handle settings and handle connections in such a way for HTTP, I can then take that profile and assign it in this drop-down box to this virtual server. And then the virtual server will use those settings to process that traffic. And the same goes for all of the different types of profiles we have defined here. There's some things in these settings that have nothing to do with profiles, like do we do SNAT or don't we do SNAT? Do I turn on address translation or turn it off? And these are, if I want to build that layer 2 load balancing function, I would just basically uncheck these checkboxes, but not a very typical architecture. But there's the ability to change things in these settings other than just profiles. Some of this stuff, like I said, snatting is right here. Is my virtual server going to listen on specific VLANs or on all VLANs? So not everything here is a profile per se, but it does tell the big IP how to process the traffic. If I were to keep scrolling down, I would get down to the resources section of the virtual server that says what iRules am I going to assign, what policies, what pool am I going to assign, and do I need persistence? And persistence is actually a profile. The cool thing about the F5 GUI, I know if you like to build command line, you're just going to do what you're going to do. But if you're in the GUI and you were to create this new virtual server and you were to put in all your settings, you were to put in all your listener, how it's going to listen, what type of a virtual server it is, you pick all your profiles you think you're going to need, you're going to get that all set up, and you get all the way down to the resources section and you go to pick your pool and you realize you forgot to build it ahead of time. The cool thing about F5 is that you don't have to build from the bottom up or the top down. You can do either. It's your choice. I could have gone in and defined all my nodes in my network that I'm ever going to load balance. I could then build all the different pools for all my applications using those nodes as resources, building my pool members. And then now that I've got all my pools built, I could go start building my virtual servers that use my pools as resources. However, if I had started out building a virtual server like I showed you at the top, putting in all my IP addresses, and I get down through all my profiles and I get down to this section, I have this plus button here. If I don't have a pool to use yet, I could click the plus button and it would bring up the build the new pool screen and allow us to build out a full pool, hit finish at the bottom, and it would bring us back into this configuration. I could scroll back down and see that the pool I just built is now in the Dropbox list. I could assign it, hit the rest of my settings, and hit finish, and I'm done. Very robust interface when it comes to being a GUI. Very proud of F5 for the way they've architected this GUI over the years and kept making it one of the industry-leading GUIs for the network gear that it is. All right. Determine if the pool configuration has an effect on virtual server state. So we've assigned a pool as a resource to the virtual server. The question here is, can that pool have an effect? Its status, does it have an effect on a virtual server? And the answer to this is simply a yes. Absolutely it does. There's 4 places within the configuration of an F5 Big IP platform we do health monitoring. 4. Okay, we do it at the node level, which means I can go monitor a node to see if it's on the wire. I can do a ping. I can do a TCP half open. I can do all kinds of network layer checks to see if that node or an IP address is on the wire. So I do monitoring at the node level. I can also do monitoring at the pool level. So I'm going to create a monitor like HTTP monitors that do an HTTP GET and ask for content from the back-end servers on a particular port, let's say port 80, if it's a web-based monitor. And I'm doing that GET to ask to see if it's up, and I'm doing it to all of my pool members. So those 2 places as a pool and as a node are the 2 different places we're going to do health monitors basically. And then the other 2 places are within those 2 fields. I can go into my nodes and do a specific node monitor. Rather than monitoring all of my nodes with ping, I could go into one of my nodes and say, on this one I want to do ping and a TCP half open monitor. I could go into my pools, and at the pool level I can say I want to monitor all of my pool members with this monitor. But I could go into a specific pool member and change its monitoring to say I want to do specific monitors at the pool member level and monitor with different monitors for that particular member. So 4 places at the pool level, at the node level, and then node default and node specific at the pool level and member specific. Those are the 4 places. We do no health monitoring at the virtual server level. So the status, how would the status of a pool then affect a virtual server like this question asks? All health monitors trickle up. Okay? So if a node is down, meaning an IP address is not accessible, any place that IP is used as a member of a pool, he's immediately offline. Why? Because the node is offline. If I can't get to the node, I can't do a get to the port, right? And then if the pool member fails, when on his health check at the pool level, if the member fails, that doesn't mean that the pool is down, but if all of the members fail, the pool will be down. And if the pool resource is down, that health status of the pool now goes to a red diamond as a whole for the whole pool, and that status will trickle up to the virtual server. So the reflected status of a virtual server is the exact status of its resource or the pool. If that makes sense. How can we take a look at this example in one spot? If we go into local traffic network map, we actually can see a screenshot of the network of all of the virtual servers we have configured on the box. Here in this case I only have 3. I can see the virtual server's name, his status, the pool name that's associated to that virtual server, that status, and all of the members of the pool. So as you can see in this example, if all of my members are down due to a health monitor failing, that makes the pool go down. If the pool is down, the virtual server's down. Direct correlations between pool status and virtual server status. Determine which tools to use in order to diagnose the issue. If you guys have already read through the blueprint for this exam, you'll notice that a lot of the bullet points for study are open-ended questions or open-ended statements. I need to determine which tools to use to diagnose the issue. What issue? Right? So because we're in this section around unresponsive virtual servers, we have to assume that's what they're talking about here. And so what tools do I have available to me to determine whether or not things are up and working like they should be in my configuration through my Big IP platform? I have a virtual server stats that I could go look at within the GUI are on the box itself via command line if I want to. I can see my virtual server statistics. Is it taking in traffic? Is it processing right now? How many current connections do I have? I could look at my pool member statistics. I could see that maybe I've got 14 out of my 15 pool members down and one is still working. That's great. I'm still green. Everything is up because one of my members is up, but I'm at 1/14th capacity right now. Things to think about are things to keep an eye on, right? I could go look at my logs because my logs are going to reflect anything that F5 has seen. If it had a health monitor that failed, it's going to log that entry. It's going to say this node or this pool member is down due to a health monitor, right? It's going to actually tell you that kind of information. So you can always go look in your logs. You can look at your connection table, your route tables. Perhaps your reason that your health monitors are failing is because you've got a static route in there that's forcing the traffic in the wrong direction, right? So route tables can definitely have an effect in a very complex network configuration on an F5 big IP platform. I can do packet captures to see how traffic is flowing and if it's flowing and what that looks like on the wire. But I like talking about using some specific tools. Sorry about that. Obviously, everybody understands what ping and telnet are. So if I'm on the big IP platform and I'm logged into the box, I can try to ping the backend node to see if it's up. Obviously, if I've got a ping health monitor already assigned and it's not succeeding, more than likely my ping isn't going to succeed. But perhaps, and that could be due to a route table misconfiguration or something to that effect. But what happens if where I'm failing is at the pool level? It's my get. I'm asking the server for content and I'm not getting anything back. One of my favorite tools to check that status with is curl. And I'd like to talk to you about it. Let's go over to the board real quick.